only on Science Channel.
Vitrell is a super durable dinnerware material invented in the United States in the early 1970s. It's made of 3 layers of glass fused together. Vitrell dishes are thin and lightweight, yet they're stronger and far more break-resistant than ordinary dinnerware. In a perfect union of form, function, and food, this company serves up Vitrell dinnerware in several striking designs. The dishes are made of 65% recycled glass from earlier production runs. To make the other 35% that's new glass, the factory combines several raw materials: sand, salt, limestone, feldspar, and 2 more types of salt. The exact proportions are a closely guarded secret. The ingredients go into a furnace, where a fiery 2,500 degrees Fahrenheit melts them into liquid glass. It exits the furnace. An extruder shapes it into a 3-ply sheet that lands in a mold, in this case, a plate mold. A trimmer cuts off the excess, while compressed air blows down from above to cool and solidify the glass. A vacuum arm then extracts each dish, and the leftovers are recycled. The dishes now undergo what's called fire polishing. Each one passes through a gas-oxygen flame, which seals the 3 layers of glass. It also melts the outer rim, smoothing and rounding out the rough edge created by the trimming. Oval dishes go on a different fire polisher, designed for an oval rim rather than a round one. Now the conveyor system flips each dish over for backstamping. The bottom of every Vitrell dish has the trade name and other information. A silkscreen machine applies the lettering. Then a gas air flame bakes the ink into the glass. Once that's done, the conveyor system flips the dishes right side up again. To decorate the dishes, a machine silk screens the design onto membranes. Robotic arms position a membrane above each dish. Then, a press head pushes the membrane down onto the surface, transferring the paint. Robotic arms then move the dishes back onto a conveyor belt. Certain dishes have a design on the outside. An automated silkscreen machine applies the paint directly to the surface. The decorated dishes now travel through a tunnel oven for 5.5 minutes. The nearly 1,500 degree Fahrenheit heat cures the enamel paint. At the end of the ride, a tempering process that makes the glass stronger. Then, nozzles spray the dishes in a soy-based silicone. This wash-off coating prevents scratches during packaging. The factory subjects a sample from each production run to a 6.5-foot drop test and a rim impact test. The sample mustn't break, chip, or crack. All to ensure this stylish dinnerware will withstand whatever your household can dish out.
His wife asked her husband to bring home a scrap of Pyrex glass to bake a sponge cake. The result was clear.
The cake baked very quickly, very evenly, and browned all around. It also took less energy and was very easy to clean at the end of the day.
Corning quickly switched gears and introduced America's first line of glass bakeware in 1915. And on the bottom of each piece is that unusual name.
Pyrex is a combination of the Greek word pyro for fire and X for low expansion glass.
Low expansion glass simply means the dish won't change shape in the oven. Today, World Kitchen shapes all of America's Pyrex at their Western Pennsylvania plant.
In the last 10 years, this facility has produced over 400 million pieces of Pyrex.
The fireglass starts as silica, a compound found in quartz and sand. It's carefully mixed with 8 secret ingredients. Then in batches of 200 tons, it's pushed into an enormous furnace where things heat up.
Inside the furnace, we have temperatures that are approximately 3,000 degrees Fahrenheit.
24 hours later, the molten glass is cut into small portions called gobs. Next, they slide into molds where a shuttle press uses hydraulic pressure, forming it into its final shape. It takes over 3 pounds of this liquid lava to make a 9 by 13-inch dish. Then a second heating called fire polishing removes any rough edges. Finally, the Pyrex is put through the test called tempering.
The tempering process gives the Pyrex product its strength and durability.
It does this by gradual heating and quick cooling, which compresses the surface and edges of the glass, removing any stress points. It's so strong, Pyrex glass was used as the windows of the Apollo and Gemini space capsules in the 1960s and 70s. And back on land, it rules the oven because it acts like a sponge.
Pyrex glass absorbs heat rather than reflects it. What that means is that everything bakes very evenly, very quickly.
That thermal technology goes into 225 different shapes each year that end up in the cabinets of over 75% of American households.
world